We've talked recently about properties of solids, liquids, and gas, and we talked about the energy requirement when you go from a solid to a liquid to a gas to change that phase, or the energy released when you go from a gas to a liquid to a solid. In fact, I did a video where I boiled water in a paper cup to show this portion of the graph that we drew in our most recent video. Today I want to talk about something called the kinetic theory of matter, and we're going to keep this really simple. There are two parts to the kinetic theory of matter for this class. Number one is all matter is in constant motion. The particles that make up matter is in constant motion. They are always moving. And the second part for this class is that motion, how much it's moving, is proportional to temperature. So if the temperature is increasing, that matter has more kinetic energy. If the temperature is decreasing, obviously, that matter has less kinetic energy. So that's how temperature relates to the kinetic energy of matter. So as temperature goes up, I'm just going to draw an arrow up for that, kinetic energy goes up. Or if you wanted to write it backwards, you could say as temperature goes down, I'm going to draw an arrow going down for that, the kinetic energy of matter also goes down. Now, if you think about that, if temperature gets colder and colder and colder, won't the kinetic energy or the amount of movement in that matter get smaller and smaller and smaller? It moves less and less and less. So we're eventually going to get to a temperature, theoretically, that is, where the molecules or atoms that make up matter would have absolutely no motion at all. Now, if they're not moving at all, what would their kinetic energy be? Yeah, their kinetic energy would be zero. Kinetic energy is the energy due to movement, and if those particles aren't moving, they have no kinetic energy at that temperature. So what kind of temperature would that be? Well, the simple answer is very cold. It would be an extremely cold temperature for the molecular motion for matter to stop, for its kinetic energy to be zero. It's been found that all matter will have a kinetic energy of zero if the temperature gets down to negative 273 degrees Celsius. This temperature is as cold as it can possibly get. You can't get any colder than that because that's when the molecular motion has stopped. You can't get any slower than being stopped. And that's what happens at this temperature, negative 273 degrees Celsius. So they've given that temperature a name. Since there's no molecular motion at that temperature, we call it absolute zero. And that gave rise to something called the Kelvin temperature scale. Well, if molecular motion is stopped at that temperature, and that's the coldest possible temperature that we can have, why not call negative 273 zero on this new temperature scale? And that's what they did. Negative 273 degrees Celsius is the same as 0 Kelvin. It's the coldest possible temperature, so why not just call it 0? Now, just by the way, we don't use a degree sign when we use the Kelvin temperature scale. We would just say 0 Kelvin. So what if, let's work to the side here, I were 1 degree higher than that absolute coldest temperature? Let's say instead of negative 273, I was at negative 272 degrees Celsius. Isn't that 1 degree higher than the coldest possible temperature? Well, on the Kelvin temperature scale, what temperature do you think that equates to? Well, if it's 1 degree higher than the coldest possible temperature, we call it 1 Kelvin. What if we're 2 degrees higher than the lowest possible temperature? So if the lowest possible temperature is negative 273 and we're 2 degrees warmer than that, wouldn't that be negative 271 degrees Celsius? Then that would be called, that's right, 2 Kelvin, because we're 2 degrees higher than the lowest possible temperature. Here, let's jump up a little bit. Let's say we're 10 degrees higher than that lowest possible temperature. So instead of negative 273, if we're 10 degrees warmer, wouldn't that be negative 263 degrees Celsius? Well, that's 10 degrees warmer than the lowest possible temperature. So let's call that 10 Kelvin. Let's do a couple more just for fun. Let's say we're 100 degrees above the lowest possible temperature. So we're 100 degrees warmer than negative 273. Wouldn't that be negative 173 Celsius? That's still pretty doggone cold. But it is 100 degrees above the lowest possible temperature. So on this new temperature scale, since it's 100 degrees above the lowest possible temperature, we call that 100 Kelvin. You see how that works? Here, let's do a few more since you're getting good at it. What if we're 273 degrees above this lowest possible temperature? 273 degrees higher than negative 273. Wouldn't that put me at 0 degrees Celsius? Well, what would that be in this new temperature scale, the Kelvin temperature scale? Well, if it's 273 degrees above the lowest possible temperature, we would call that 273 Kelvin. Here, room temperature. Let's try this one. Room temperature is typically about 23 degrees Celsius. 23 degrees Celsius. How many degrees above the lowest possible temperature is 23 degrees Celsius? Think about that for a minute. So we're at 23 Celsius. The lowest possible temperature is negative 273. How far above the lowest possible temperature is 23 degrees Celsius? That's right. If you said 296 Kelvin, you are correct. So room temperature is about 296 Kelvin. Let's do one more, the boiling point of water. Now the boiling point of water normally is 100 degrees Celsius. What would that be on this new temperature scale? 100 degrees Celsius. How much higher is that than the lowest possible temperature? Think about it for a minute. The lowest possible temperature is negative 273. We're now at 100 Celsius. Isn't that 373 degrees higher than the lowest possible temperature? So we call that 373 Kelvin. So, if you think about it, to find the Kelvin temperature scale, didn't we simply add 273 to these Celsius temperatures? Yeah, if we added 273 to each of these temperatures here, we ended up with the Kelvin temperatures. And if we want to find the Celsius temperature, and we know the Kelvin temperature, don't we subtract 273 from the Kelvin temperature to find the Celsius temperature. So there's an equation here at the bottom of your notes that will help you with that. We're going to practice this on the next video. Okay, Celsius to Kelvin. Remember, the Kelvin temperature scale is based on the absolute coldest possible temperature. We decided to call that 0. That sort of kind of makes sense, doesn't it? All right, that's good enough for today, kiddos. We'll talk to you soon. Bye-bye.